Okay, in this video we're going to run through an example of how we can match up a two-way table and a Venn diagram and then find some information about it. So first of all, let's have a look at our Venn diagram. We have that over here. So there's our Venn diagram. You can see in there we've got our intersection of 1, our A only 2, our B only 6, our not B, not A is all there with 3. We need to transfer this information into the table. So I'm going to make that A, and that one not A, that one B, and that one not B. I'll get the bits around the right way. Then we have some totals that we need to look at. Okay, so in our intersection, alright, so there's our intersection. That's 1. Alright, so A but not B, so our A only. That's going to be in the next one along, and that's 2. Next one down, we've got B only. So there's our B only. B only is 6. And then what's in none of them? So not A and not B is the 3. So that goes in there. So now we total it all up. We go across the first row. Well, 1 and 2, well, that's 3. 6 and 3, well, that's 9. 3 and 9, well, that's 12. Now, the other ones should also add up to a total of 12. So 1 and 6, well, that's 7. 2 and 3, well, that's 5. 7 and 5, that adds up to 12. It checks out. So there's our total. Okay. First thing we've been asked to do is find the number of elements. So remember, use the right pen. That means number of elements. In A intersection B. That's what it's asking us. So the number of elements. So the number of elements in A intersection B is this section here, so that is 1. Okay, that one is 1. If I want the number of elements in not A but intersection B, not A intersection B, that's this one here, that's that 6. So not A intersection B. So it can't be A, but it should be B. All right, it's not the not B's. It should be B, but it can't be A. That's going to be 6. The number of elements in the A intersection not B, that's where it can't be B, but it has to be A. Can't be B, but it has to be A. That's our 2. If we want not A and not B, so remember the intersection means and. That's when our 3 comes into it. Then the number in all of A, so that's our total over here. That's all of A in here. So that one's going to be 3. All of not B, so that's anything that's not B, so that's that 2 and that 3 outside, so there's 5 in that one. Okay, in not B there's 5. And now we want A union B, so we actually want all 3 of these put together. Okay, so 2, 1 and 6, that's going to be 9. Alright, so that's how that one is working. So that's how they all work. Now, in terms of the actual probability, let's use this Venn diagram to find the probability. Okay, I want to find the probability of A intersection B. I want to find probability of A intersection B. I'm going to start like normal with my probability of the event. Over the total number of outcomes. Then we fill in what we're looking for. Now, how many times does A intersect with B? Well, that's that 1. That's this one here. So it's 1 over our total, which is 12. So it's 1 over 12. If I was to then find the probability of not A, I want to find the probability of not A. Same setup, minimum of 2 lines. Same setup. Probability of not A. So you can see here we're actually shortening what we've been doing. So before you learnt this notation, you would have actually written the word not. So not A, N-O-T-A. That little line cuts us out writing that word not. So we're looking for not A. All right, not A. Well, there's 6 that are in B, and there are 3 that are not in B, that are not A. So that's when we go for our 9. So this one is 9 over 12. And this obviously can be simplified to 3 over 4. Alright, so that's just simplified to 3 over 4. And that's how it all works. Hopefully this has been very helpful to you, and see you in the next one.